Hey, it's James Governor, co-founder of RedMonk, and we're here for another MonkCast, talking about what else would we talk about in 2026, but of course, AI. I'm here today with Paul Brookes, a senior AI engineer at a
Hello.
company called TurinTech. TurinTech is it's kind of a bit of an AI OG. It's been around in the UK scene pre-LLM at least.
That's right.
You weren't launched 18 months ago. You're a company with a bit of history. So why don't you tell us a bit about sort of TurinTech and what you tell us a bit about TurinTech.
Sure. Well, indeed, we have been around for a few years, in fact, before generative AI, and we've focused the whole time on really complex optimization problems. So whatever business that may be in, maybe it's financial, maybe it's logistics, we have a platform to deal with that. And in particular, we have a platform for performance optimization of code, which is focused very much on applying genetic algorithms for those optimization tasks. And of course, before generative AI, you could do that with all sorts of techniques like pattern matching and recognition and so on. But basically, since the onset of LLMs, we have a huge new array of tools that we can use to optimize your source code.
Okay, and you have, as all companies have in the software industry, had to respond to this onslaught of code from LLMs, to the change in working practices. So tell me a bit about, or in fact, even the use of models, because I understand that you're
Yeah,
kind of a bit of an inferencing nerd. Is that is
that is fair to say. That's fair to say. So, obviously, um, everyone has this huge desire for tokens, and we're not like unlike anyone else. Just we also are heavy consumers of AI. But being a performance optimization company, we do get to use our tools to actually look inside those models and figure out what exactly is it that we can tune up and boost in order to get the most tokens per second and the best cost basically out of all the models that we're using.
Okay. And on the inferencing side, I mean, so that's your own models, but what's happening sort of in customers? Because I think at the moment
Yeah.
we're optimizing inference is quite new
Right.
as a field, certainly to if we think about your customers, it might be financial services or
Yeah.
telcos or something like that.
Yeah.
Yeah, the state of the art and inferencing is it's early days, isn't it?
Well, I mean, there's a massive market out there for it, and in fact, we're very pleased to be working with some leading semiconductor companies on that. In particular, we get to work with Intel on their
Hmm.
OpenVINO inferencing framework, their toolkit, and also we get to optimize vLLM for Intel hardware. And it's pretty in depth. I mean, it really goes all the way down the stack. Right from the end user, how are they consuming the model, all the way down to actually what are the particular instructions that are best for this specific piece of hardware to tune the model for that particular chip. So
So semiconductor companies are your sort of they're your canaries. I mean, canaries in the coal mine. They're the early customers.
exactly.
Other you were expecting other organizations are going to be using their own models and optimizing themselves.
Absolutely. I mean, foundationally, obviously, the semiconductor companies want to make sure that people are getting good experience on their hardware, that they're able to get inference on their hardware, at the kind of optimum level. Um, and so, they sit at the bottom of the stack there. But everyone else really wants to get in on this as well because they are concerned about cost and security. They want to deploy their own models. They may be a bit more hardware agnostic, but they may have other kind of metrics that they're trying to optimize for, and they really want to get the best out of their particular use case on whatever hardware it is.
Okay. And so you mentioned those examples with Intel. What are some of the let's drill into that. Sort of where you are. Are there any um always examples like
Right.
sort of what is it that you most enjoyed working on, or some of the interesting challenges?
Well, I think that when you're carrying out optimization on LMs, as I mentioned, you do go all the way down to the stack, and you get to see a little bit about how those models are kind of represented inside those inference engines, right? And how do you optimize? Well, there's so many different ways. One way is through kind of model compilation, where you kind of search through this huge graph of the model in order to figure out which operations you can fuse together to make the best use of your memory bandwidth, or reduce something called kernel dispatch overhead, which is a very, very nerdy topic. But also,
Go for it. Tell us all about kernel dispatch overhead.
right. Well, for example, obviously, many people, when they're running models, they are running them on GPUs. And if you are running on, say, a laptop with a CPU and an integrated GPU, then when you run inference of the model, as you move through the model, every single operation will at some point be dispatched onto that hardware. So from the host sort of CPU of the laptop to the device, which is that integrated GPU. The thing is, there's a lot of bookkeeping when you do that, right? So every single thing has to be sent off, almost like, I don't know. I mean, what's the best analogy? You might think of, well, I don't know. Maybe you'll talk of sending a parcel or something like that.
Yeah.
Who knows? Anyway, you basically have to send off all these kernels onto that hardware. And if you're running on a workload where you're having like a single conversation, actually there's not too much work to dispatch on each token of that conversation. But if you're trying to get the very, very best performance for a single user, on their local device, then this is a big problem. You're completely underutilizing your GPU. So what you can do really, and what is widely done is kernel fusion, which is fusing together the kind of the operations that are being dispatched onto that GPU into bigger and bigger jobs. So, all that being said, when you have a framework that has some kind of compilation layer that kind of scans through your graph and figures out what are the best things to fuse, you can basically do a lot of different heuristics to kind of tune exactly which things to fuse up and how exactly they're going to be put together into these bigger packages of jobs that are dispatched onto the device, which is perhaps a bit of a mouthful, but it's way down there, and I think it's never been a better time to know about how these things really work.
So did you? I mean, I don't know how closely you follow. Well, I mean, partly it's partly the Microsoft world, so I'm not
Right.
sure. But so Nvidia's Spark RTX chips were announced last week. They're basically, I don't know whether this is, so I'm given you're nerding out about hardware and possibly running models locally, there's going to have to be a lot of work in that space. Basically, Nvidia is doing something that's a bit closer to what we've seen in terms of Apple Silicon.
Yeah.
So load of ARM cores,
Hmm.
GPUs, 128 gig of unified memory,
Right.
an architecture that's a lot more like what we've seen, as I say, in modern Apple laptops. And so I think for them, obviously, and for Microsoft, well, I mean, there's two things. A, it's going to make games really awesome.
Yeah.
As a gaming platform, it's going to be very sweet. But obviously for AI workloads, I think the hope from Microsoft, and this is definitely something that Apple's going to benefit from as well, as we begin thinking, hang on a minute, do we even need to be running, or could we be running more of our models locally?
Yeah. I mean, I think it is a very important thing to be thinking about, because costs really are pretty much exploding. I mean, and you see that in a lot of reports around. I mean, I think the COO of Uber was pretty shocked by the cost of AI recently, and I think they've burned through their entire yearly AI budget in about 4 months.
To be fair,
Yeah.
Uber as an organization, I thought it was interesting
Yeah.
looking at this, because of course they have a history of burning through money. And
Right.
you have that near death experience
Yeah.
of those sort of large, extremely tech savvy organizations. It was no surprise to me
Yeah.
that Uber was the one that went, hang on a minute.
Yeah.
We are a company that has to be about managing cost.
Yeah.
And tokens is one of the costs to manage.
I mean, AI is so useful in so many jobs, but you're not going to necessarily solve all your problems by just setting fire to piles of money, right? So I think it really is important to kind of.
I've been saying that the real bitter lesson is your Anthropic bill at the end of the month.
Yeah, it's you can have a wild ride, and of course, you can prototype all kinds of things, and you can learn so much.
Yeah.
But I think it is very, very important to direct that towards some kind of real evaluatable kind of validated criteria, right? So whether that's performance optimization, you have benchmarks, some harness that's telling you if you're getting the most out of your AI, or well, some other metric, um, some other kind of business KPI. And I think, what we're also seeing is that basically the quality of the hardware that's coming out, and also the quality of the open source models,
Hmm.
whether that's Kimi K2 or Qwen, the latest Qwen versions, it's pretty much reaching that point where you can actually start using local coding agents on this hardware
Hmm.
that are really delivering value to you.
Yeah, 100%. I mean, the amount well, the amount of investment that's gone in, but the quality of uh, certainly Google's Gemma models, even running on like phones and stuff.
Yeah.
Again, I mentioned Microsoft. They announced a whole new suite of local models called Ion last week. Um, they already had some small models. I do think the
Mm.
small model thing is, I mean, it's funny. What is small? Do you know what I
Yeah.
mean? It's like, oh, 30 billion parameters is a small model now.
Yeah. Yeah.
So, but yeah, what do you, as a nerd, are you like, what do you run locally? What have you found interesting in terms of some of the open weights models that you've just mentioned?
Yeah, I mean, locally we run Qwen 3.6. I think it's 35 billion with 3 billion active parameters. Okay, so this is a mixture of experts model. So it really does pack a pretty good punch without having to, use all parameters in the network simultaneously. Um, and what you're seeing is that this is able now to perform like more complex tasks, algorithmic challenges, or perhaps tuning of the LLM itself, as I spoke about, when you're looking at the kernels or the compilation passes. I think it's a very, very effective model, but of course it's just one of many. I mean, Nematron is there, and Kimi K2 2.5 I think is also a very powerful one, but that ends up being actually not a really small model at all, because I think that's several hundred billion parameters. So not something that you'll run locally.
Hmm.
But yeah, I think certainly out of the Qwen models, we get a lot of good performance.
And what do you? I mean, I mean, what does your infrastructure for testing look like? So you've obviously you must
Yeah,
have, I mean, an absurd. I mean, yeah.
yeah,
What do you? Yeah. How do you test at TurinTech?
sure. Well, okay, so we do have access to some of our own hardware. We have servers with various NVIDIA GPUs or Intel CPUs, but we're also out there, using GCP instances. We have basically Intel Granite Rapids bare metal hardware on which we can actually profile these models that we're running. So I think actually that's one of the really important points, is that if you are doing this kind of performance tuning, you need to not only be able to access just some cloud instance, but you actually need to be able to access it without having some kind of hypervisor in the way that's blocking you from really working with the hardware counters on the hardware itself.
Hmm.
Because you want to bring to bear all the profiling tools possible that you can then kind of aggregate this information for your coding agents to perform that tuning.
Okay.
And so that's one side of the infrastructure, is really the hardware itself. But on the other side, we have our platform, our own performance tuning platform, which is Artemis, which basically combines together kind of a knowledge graph of past results. So you can learn from the past and perform some iterative self-improvement. And we use that to really, power the dispatch of coding agents across these code bases
Hmm.
in order to find the optimal tuning. And then on top of that, of course, you have the benchmarks that really sift the signal from the noise and figure out what it is that should be presented to the user for 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 review.
Hmm.
So it's a
Okay.
combination there from hardware to software.
So can we go back to Intel a little
Sure.
bit?
Yeah.
Um, so you mentioned two projects that you've worked on with Intel. Like, to what level? What does that partnership look like? And what does it feel like when you get a breakthrough that like where you're seeing a significant performance improvement? So I'd love
Yeah.
to sort of drill into a bit about maybe some of the techniques
Yeah.
that you that have shown value in terms of the optimizations you've done at Intel.
Yeah. I mean, I think the partnership, it feels it feels very, very good to be working with basically some of the, the world's best semiconductor companies, right? But the world's best hardware companies. And it's really great validation when you reach a point that that you're able to surface something interesting. Of course, it can take a lot of work, and I don't think AI can ever completely, replace that kind of human expertise of knowing exactly the system and how it works really, really well. But I think in partnership with a bit of elbow grease, a bit of validation, and a bit of iterative improvement, you can really make some breakthroughs in performance tuning. And I mean, when you see them, you always have to like take a bit of a step back because I think there are a lot of times when random fluctuations or noise will
Yep.
make a particular thing appear better than it is. If you take a deep breath, and you measure and you remeasure and you A/B test, then you can then you can start to celebrate. So I'd say one of the biggest things I've learned there is really to not celebrate too early. To just take a breath,
Yeah.
work through it.
Yeah.
Yeah, but take another look, and then you'll see.
Okay.
And a lot of the time, you'll get good results.
So in terms of technique and just sharing a bit of your knowledge, like what are um what are some of the key areas that, like, if I was if I was working in an organization and I knew that we were going to be doing more work around optimizing inference,
Hmm.
like what what should I be focusing on learning?
Hmm.
What tool, I mean, other than Artemis, of course,
Yeah.
what sort of tool sets and approaches should I be learning and focusing on?
I mean, I think the most important thing is to have some clear kind of value criteria for what you're trying to optimize. And that actually, I think, is very tough. It's not like everyone approaches a problem and they've immediately gotten the most sophisticated, benchmark and unit testing suite that tells them exactly whether they solved their problem. That can come down, a little further down the line. But I think really setting your benchmarks close to what you're really trying to solve um, is very important. You don't want to develop benchmarks that are only there because they're easy, because you have all the necessary data. You might need to go out and collect some data, collect some examples, and that's where the work comes in, is to actually figure out what your target is. That's what I would say really about the high level. And then if you're, if you want to, nerd out, then you learn about exactly what's going on in the kind of different sorts of performance bottlenecks you can have on that piece of hardware if you want. But I think connecting the whole stack together is quite important.
Yeah. So, like, I guess I mean, what was your journey to being someone that actually worked at that low level? Like,
Hmm.
sort of, yeah. So, I talked to one of your colleagues, Mina. Her background's neuroscience.
Yeah.
Like, how did you? What was your route into this world?
Right. Well, I actually have a background in physics,
Yep.
so I guess I've always had an interest in the fundamental. Um, But, I did take some kind of detours from that. So, a few years ago, I finished my PhD, which was on topics of quantum computation and superconducting circuits. From that, I actually moved into data science. So, at a much higher level, dealing with software and data and trying to solve, much more sort of much more higher level problems, whether you would express essentially as business problems.
Hmm.
But I think I always had that kind of pull to delve a little bit deeper again. And I think this is like really the perfect opportunity for that.
Yeah. So
Now,
working with the semiconductor companies is a lot of fun.
yeah, basically that's it.
Okay.
You know,
Okay.
that's the draw.
So AI engineering. So I mean, again, that's another reasonably new discipline. So
Yeah.
you're a senior AI engineer at the
Hmm.
company. Tell me a bit about, like, what do you think an AI engineer is, and what does your team do?
Well, yeah, right. AI engineer, obviously, it's a fairly new term. Um, And yeah, I think best described by what those people do. But The problem is that actually it can be a wide variety of things. It can be pretty cross-functional. So of course, there's ML engineering, which can cover, the building and deployment at scale of ML solutions, ML models. That's the one side of it. But then there's also now that we're empowered with different AI coding tools, you actually get to deliver, much more across the stack. So you can demo your projects much more easily. You can basically show off what your kind of prototype solution is. And you can take that all the way to the customer, almost like a solutions engineer or forward deployed engineer.
Mhm.
So I think one of the things really is that basically now that we have access to so much tooling, we can bring together a lot of different technical and commercial and kind of customer facing elements into that overall role of AI engineer. Although some people might be much more specialized within that.
Do you think, I mean, how important do you think that FD, the front forward deployed engineer, will be in terms of like your work going forward and your ability to engage with customers? I mean, how much domain experience do they have? They sort of know they want to improve something,
Yeah.
but they do you find that a lot of your customers like, yeah, we love the software, but could you just send us a bunch of consultants? Like, what's the balance? How do you sort of manage that challenge?
I mean, that certainly is a challenge. And the thing is that, when you want to provide a product that does performance engineering, it is a tool, but it's only one half of the equation, and you need to have a lot of expertise in order to use it correctly.
Mhm.
So I think you do need some work there to kind of bridge that gap, explain, how is this delivering value to you, and really I would phrase that in terms of you need to basically to demonstrate some hook of this is one of the small things that can be done, with this tool that adds value to your workflow, and now hand it over for you to take it forward. So you need to really align those two things and kind of bridge that gap. Um, but I think it's certainly like a quite a fun place to be, and lets you learn about all sorts of new problems.
Yeah, 100%. Well, we love that. Solving problems, lots of optimization. I say your colleague did a nice sort of judo move, and token maxing is now not burning as many tokens as possible,
Right,
but using them more efficiently.
that is true. It should be.
It should be, shouldn't it?
Yeah.
I certainly think that measuring people's performance by how many tokens they burn is kind of daft. One of the silliest things I've heard.
Yeah, I would not advise this
Yeah.
in general. But if if you have a harness that tells you if you spend your tokens well,
Mhm.
and if you're learning from what they've done by basically you know a knowledge graph of your past results, then I think you know burn away. It's as long as it's in helping you
Yeah.
achieve your goal.
Tell me a bit about the harness question. So, are you building a harness now? Would that be a reasonable way of talking about what you're building, or you more integrating with harnesses?
Well, I think so. We have the discovery feature inside of our platform. The discovery feature is essentially a way of tying together agents with the tools that they need to record and learn from past results and benchmark what the performance was. So in that way, I really see that as a harness, but not just a harness. It's really something that kind of, it doesn't just keep you on the rails. It really helps you improve over time. And I think that applies not only to the model itself that's performing those changes, performing those code edits, but the user who can now look through a review of all the experiments that were done, all the ideas and hypotheses that were evaluated, and see what worked well and what didn't. And I think that really that's probably the best way of using AI, is something that can kind of feed back into you as a user, and that you can then learn from as you go forward.
Okay. Okay. Well, yeah. That's a little bit of nerdery around optimization for model inferencing. It's Paul, James. This was another MonkCast, RedMonk conversation. If you enjoyed this, want more content like this, please smash like, hit subscribe, share with your friends, all that good stuff. But yeah, I'd just like to say, Paul, thanks very much for joining us today.
Thank you very much.